So let's say this is a quadratic equation and I want to form a symmetric matrix from it.
Okay.
I mean, the matrix from which this quadratic equation has been formed, I want to do reverse engineering and to find out what's the original matrix. So, how I did it, how will I do it? That is, just see this is x1, x2, x3 square, that is the coefficients, the leading coefficients. So, if you compare the
Hmm.
leading coefficients here, A, B, C, they go here in the leading diagonal, principal diagonal, right?
Got
So
it.
I'll write them where? 10 to 5, right?
Okay. Noted.
Now, next comes x2, x3. This coefficient, this is 6. So x1, x2's coefficient is double here, but it goes here x1 and x2. This is x1, this is x2. Here in these two places, but half of it. So,
Oh, that is it?
yes,
I thought we had to reverse solve it. I
no,
was looking for ways I could do it. Oh no, this is fine. This is fine. Oh, this is very self-explanatory then.
yeah. So basically, this
X1, X2,
is,
then it becomes 2.
you need to see where is x1, x2? Here. And this is minus 4. So
So
x1,
-2.
x2, this becomes minus 2.
Got it.
Now, I need, this one is what?
2x3.
X2, x3 is E, which is here, 2 and
2e.
third
That is,
position.
yeah. So that's
So this
3.
becomes 3. And rest one, this becomes minus 5. Right?
-5. Yeah. Oh,
Pretty simple.
yeah.
Hmm. Now, once you get this symmetric matrix, then you need to find out the principal minors for this to see whether it is positive, indefinite, positive, definite, semi-definite, or what. So what I'll do, I'll find first minor, that is D1, that is
D1.
the determinant of first element, that is nothing but the first element only, right?
D1, 1, 10.
Correct.
10. Got it.
Then,
That's
so
the
this is
first
your
one.
first order minor.
Hmm.
Then
Then
in
D2
order to
would
get
be
correct,
20 plus 4, 24.
correct. So this one is also positive. This one is positive. Now about third order, the determinant of whole
Yeah,
symmetric matrix.
the whole symmetric matrix. What is so 10 into 10 minus 9 plus 2 into 5 minus 10 minus 15 minus 5 into 3 to the minus 6 minus 10. So this is equivalent to 10 plus 2 into minus 25 minus 16 minus 5 into 16. So it's gonna be negative.
I got 0. See where this is 10. I'm hiding this. This becomes 5 to the 10 minus 9. Then did you apply here minus sign at odd place?
Yeah, so it becomes plus.
Plus 2. So 5 to the 10 minus 10 minus minus plus again 15. And
minus
then
10 minus. Oh,
this,
okay. No, no, no. My bad, my bad. Yes, minus 5 minus.
and then minus 5, minus 6, minus again 10, plus 10.
Yeah. Yeah. 0.
So tell me, if 0 is here and rest two are positive, which condition is it?
So a positive semi-definite.
Perfect. So this is how we
So the
calculate.
range is positive definite, semi-definite. Yeah. Got it.
Got it? Now let's
Got it.
try your question paper here. Is it? This is 2021. Yeah. Read the question. This is of 20 marks total.
Got it.
You need to consider this quadratic form. Firstly, what is first part is asking for?
Identify the symmetric matrix of coefficients, ठीक है, associated with this quadratic form, satisfying QX. Okay, then find out principal minus. Oh, damn, nice. There are three principal
Correct.
coefficients.
Correct. So this is AKB. They go here
Right.
in the diagonal.
Got
Then
it.
you get x1, x2 here. X1, x2. Half of this
Got it.
coefficient. So that means this
So
is A,
that's one.
right?
Yeah.
And then you have x2, x3. X2, x3. Half of this. And you don't have actually x1, x2. You can't help it. It is 0,
0.
right?
Got it. Got it. So it becomes 1 1. uh, T3 equals A into BK minus B square minus AK plus that makes minus, which is equivalent to ABK minus AB the whole square minus A square K, which here means
That's correct.
uh,
So in all of these undefined values, you need to consider all of them. So you are done till this part, right?
yeah, yeah. So I'll
Now,
tell you my principal minor is A.
hmm,
My sorry, my first order minus A, second order minus AB minus A square.
hold on. This should be AK minus A square.
Oh,
We take only first four elements like this, right?
oh, yes, AKB. Yes, yes. Oh no, then yes, AK minus
Yeah.
square. Just 1 second. Then D3 I'll calculate.
Done.
Yeah.
Now, the second question is asking me what it means to be indefinite, positive semi-definite, and negative semi-definite. Now, it is just asking me to define first. So you need to tell me, you need to say that because parameters are what? A, B, and K. So you need to say when I'll get QX greater than 0 for some X belongs to R3, and I'll get QY less than 0 for some Y belongs to R3, right? What does it mean? I'm getting two values. One is positive, one is negative. That means it is indefinite, right or wrong? So
I'm
this
not able
is
to understand why did we choose QY
okay.
less than
So
0?
this is general. I need to put two values, right? If you are choosing qx1, then it's fine. You want to choose qx2, you want to put another value, qx2, then it's fine. You just need to define it for one particular set that this belongs to 3 by 3 order matrix. Yeah.
Okay, over here, what does it mean when they say R3? R
R3
is to
means
3.
CD space, 3 by 3 order matrix, 3 rows, 3 columns. When it is about defining what it means for A to be indefinite, that means it will fluctuate between positive and negative values. When it is positive semi-definite, so you have to say that if it is greater than or equal to 0, correct?
Yeah.
For some x belongs to R3. And it is also asking me to define negative semi-definite for A. So if A is giving me a qx, which it is less than equal to 0, then it is semi-negative. Semi-definite, negative semi-definite. This is just the definition. This part is general. You have to explain it. Then it is asking me to specifically talk about the parameters ABK such that this is indefinite, positive, definite, and semi-definite. So for that, what I'll do, you've got it. Do you want to note it down? Or it's fine, you have it.
The all the parameter values for ABK such that the quadratic form is respectively indefinite, positive, semi-definite, and negative semi-definite.
Yeah. So what do you
Uh,
do for that? Can I erase?
no, no, 1 second. I'll take a look.
Correct. Do you remember when we define, I mean, how did I get this qx? It is when I will be, because it is x1, x2, and x3. So I must have put it as x1, x2, x3, its
Yes,
transpose,
the
then the
transpose.
matrix,
Yes, then the
and then
matrix
the
into
column.
the vertical
Yeah.
vector.
So that means when I'll open this is the form, and I can put the value of x1, x2, x3 later on. Any of the values in x1, x2, x3. So if I'm getting after, let's say I'm putting x1 as 1 and I'm getting positive
Okay,
value. But when I'm putting x2 as -1 or let's say 2, I'm getting negative value. If I'm getting both of the values, one is positive, one is negative, for any such exception with wherever you can find out, from that set of R3, then you will say that it is indefinite. Is it fine?
got it.
So that's why I'm considering for indefinite one two variables at least, two variables x1 and x2. Then only I'll be able to get different values, right?
Got it. At least two.
Yes. So that even if my x1 and x2 are coming out as positive, but if x3 is negative, then it works for indefinite.
Yeah,
Now, to make it more precise, like specific about the question itself, now it is asking me this way you have generalized it, that this is the case when it is definite, semi-definite, indefinite, whatever. Now this question is asking about exact values for which it will be. See, now find all the values of ABK for all these parameters so that this is indefinite, positive, and negative semi-definite. Okay. So how would we do that? We know if D1, D2, D3 all are greater than 0, then it is the case of positive definite.
yeah.
Positive definite is not asked but. So let's find out positive
Indefinite, positive,
semi-definite. Yeah. Let's, so for
greater than
semi-definite,
equal to 0.
correct. That means I simply put all these values which I got. That is first one. A should be greater than or equal to 0.
Okay.
So this is how I have generalized it. Then my T2, that is AK minus A square must be 0.
Must be e greater than equal to 0.
So I have
And
got
D3,
my A value. I have got my A value from first one. So I need to get K value for this one because I need to find out all these three values. So let's find out K from here. What it will be. If I take A common, it will be K
so
minus
K
A.
minus A
So A
greater
is
than
greater
equal to
than 0
0.
and K minus A
Yes,
is greater than or equal to 0. That means K is greater than or equal to A,
greater than or equal to A.
right? So that means K is greater than or equal to A and A is greater than or equal to 0. This is one relation which we can find out, right?
Okay.
Now, third one, I need to find out the value for B. So for that, I'll put D3 greater than or equal to 0. That means
Right.
AKB minus AB square minus A square B greater than or equal to
A
0.
square be greater than 0. Yes.
So what you will get from here, you need to find out B. First of all, can I divide the whole equation by AB?
Yeah.
Whole inequality basically, not equation. So AB, if
Yeah,
I divide,
inequality.
what will I get? K minus AB is gone, so only B, then AB is gone, only A. Because I cannot do it this way that I keep AB, then I'll not be able to segregate B fully. I need B on one side and rest of all on the other, right? Are you getting this?
Right. Right. For me to define B. Yes.
Yeah. So minus B is here. It will be minus K plus A, right?
Plus A. Yeah.
And do you know the speciality of inequality is this? If you
Yeah.
multiply,
So multiply or divide, it the sign changes. So in this case, it becomes B less than or equal to K minus.
is this fine?
Oh. Yes. Just 1 second.
Not only this one, if I took AB as common, right?
Yeah.
So that means AB is also greater than or equal to 0. This is also one case, right? This factor is also greater than or equal to 0, isn't it? If I'm saying divide this whole inequality by AB, instead of saying that, can I do firstly AB as common, then only K is left here,
K
minus
minus
B,
B
right?
minus A.
And then just like factorization, I can keep one by one,
Yeah.
all of them greater than or equal to 0. A is greater than 0, B is greater than 0, and B is less than or equal to K minus A, right?
Yes.
So this is how we've got this. If we generalize, so see, B is less than this, but greater than 0. So my inequality becomes, just bear with me, let me find the space to write.
How do we know? I didn't get the last. So we took AB common.
Uh,
Uh,
okay.
that I understood. Now
Uh, Now, these are three
I understood
factors.
that step.
So A is greater than 0, B is greater than 0, and
Right.
not this one. Where is it? Third one is
Oh,
this, right?
yes.
Now, once I get it,
So
if
over
I
here it's
relate, uh,
AB is greater than or equal to 0
yeah, so
and
age
K
I
minus B
separately write.
minus A is greater than or equal to 0.
Correct, which is here. Is this fine? Or is
Right,
this
got it.
hodgepodge? Okay. Um, so you got this A greater than 0, B greater than 0, and B is less than or equal to K minus A. Fine?
No, I did not get how did we get B greater than 0 or equal to 0?
Okay. basically AB is greater than 0, right? So these are
Right.
also two factors, right? So A is greater than 0, B is
Right.
greater than 0. This product can only be greater
Right.
than 0 if either both are negative, then also it can be positive. Are you
Got
getting?
it. Got it. Yes. Yes. Yeah.
So if
Since we have
I,
already defined that A is greater than or equal to 0,
correct,
B all has to be greater than or equal to 0.
correct. Now, if I relate this, let me change the color of the pen. If I relate this, and this, what will I get? P is greater than or equal to 0 and less than or equal to K minus A. Is this fine? This inequality.
Yeah.
Is this fine? So can I add A to all of these? A plus B, K. Is this fine? You can leave the answer up till here also or this way. Why I'm telling you this? Because
Yeah.
your solution goes this way. Is this fine? I've added, I mean, I want it to be separated. Separate K, separate A. If you want the value of K, so K is the biggest out of these. Is this fine?
Got it. Yes.
Yeah. You can jot this down. So that's why it is 12
Cool. I've
marks.
taken a screenshot.
Okay.
Yeah, and now I have to see how I could present this the answer.
You can take your time. We are doing a lot of questions on this. Don't worry. You will gradually learn. I mean, this is the practice. When you do it on your own, then you will master this.
Right.
Yeah.
Cool.
So, so first up, every question I have seen in all of your question papers, firstly, they are asking to find out symmetric metrics. Then they are asking to
Hmm.
define general indefinite positive semi-definite definition. And then they are asking you specifically these coefficient, what's their value when it is positive, when it is negative. That's it. This is all about the question, okay?
Got it.
Now the last part which they are asking, this 4 mark, is to plot the value which you got on the graph.
Okay.
So that I'm going to show you using Desmos. We do
Desmos.
it together. I mean, all together for all of the values. Just stay tuned.
Okay. I'll just be back, ma'am. One second.
Yeah. So, Puru, what you have got? One is if it is semi-definite. That's why you are using this greater than equal to sign everywhere. Then A is greater than
Yeah.
0, B is greater than 0, and K is greater than A plus B, right?
Yeah.
And when again you have to do it for negative, semi-definite. Then you will
Oh my
reverse the
God.
sign. That's why it is of 12 marks.
Oh,
Okay.
this is
Uh,
interesting.
have you taken the screenshot? Should I erase?
I've taken.
Yeah, okay. Now, if you look at uh, which one is it? This is the next one, no? Huh. Now, they have combined it, another form, but the question is, essence is same. Could you please write the symmetric matrix for
Yeah.
this?
A, B, A is my principal diagonal. next to next to 2a.
Perfect. So this part is done. Then it is asking me to find the symmetric matrix of principal minors.
Got it. D1 is a. D2 is going to be AB minus a square. D3 is going to be a into AB minus a square minus a into a square. ठीक है. A square B minus a cube minus a. Oh, my is equal to a square B minus 2a cube.
Yes.
Yeah.
So done. Now they are asking me what it means to be indefinite, semi-indefinite for a matrix. So,
So I'll define that
hmm,
uh,
that is fine.
as
That you can do
hmm,
based on the definition. Now you tell me about these parameters. You have to tell me what will be the value of A and B for firstly, so indefinite, you will find that for indefinite, you will say sometimes D1, D2, out of any of these, sometimes they'll be greater than 0 and sometimes they'll be
yeah.
less than. So this will be general. But for positive semi-definite, you will write D1 is greater than or equal to 0. So my A is greater than 0, greater than equal. Now tell me about A and B for rest of this. Yeah?
Got it. So B minus a greater than or equal to 0.
So if you do factorization and you
So
one by
this is
one put greater than or equal to 0.
B minus a greater than or equal to 0. Oh, huh.
So if D2 is greater than or equal to 0, that means AB minus B square greater than A square. So if I take A common,
So it's a b minus a greater than or equal to 0, which is a. See, we know a is greater than or equal to 0. Thus b is greater than or equal to a.
correct. So this is 1. And now if D3 is greater than or equal to 0, then what will be the
So a
case?
square b minus 2a cube is greater than or equal to 0. Then you take a square as common.
Right?
It's going to be b minus 2. So we know that a is greater than or equal to 0. Thus a square is going to be greater than or equal to 0. Then b minus 2a is greater than or equal to 0.
Hmm.
So b is greater than or equal to 2a.
2A. Now, if you want to plot it, then what you will do,
Hmm.
consider Desmos don't take constant values. So you have to, instead of B and A, if you do X, B is Y, A is X. If you graph this, so let me show you.
So
I need to remove it. Can I?
yeah, ma'am, I've written it.
Okay. So see, if you go to Google and type Desmos and you sign
Hmm.
in, here, okay, so what will happen? My one equation is X, no, Y is greater than or equal to X, right? If you write only Y
Hmm.
is greater than X, so you will get this what? Slack line, these dotted lines. That means this shaded area, it is showing this is the solution. whatever you will choose, for
For
example,
all
0,
y.
0.
Hmm.
This 0, 0 is not the solution. Why? Because it is on this line. This border is not included. But if I write equal to, right? If you write, you can write it using keyboard, or here also they have given the keypad. So you can write it
Got
from
it.
here also. Greater
Oh,
than or equal to.
understood. Now it's
So
not dotted lines.
yes. So it is not dotted. So whatever it will be there, if you put here 2 comma 2 is also the solution. Everything which, including this and above. So everything which is x, y is equals to x is what? 1, 1, 0, 0, 2, 2, 3, 3, 4,
Yeah,
4, all these points.
the
So all
45
these,
degree line.
yeah, all these are included, and above them, everything is included here. So what will happen? You will say that if y is greater than x, for example, if I'm saying b is greater than a, this is what it means, right? B is greater than or equal
Hmm.
to a. So that means you will say the positive value for greater than or equal to, this is my positive. What was the condition? Positive semi-definite, right?
Positive 7 definite. Yeah.
If I do less than or equal to, instead of
This is
this,
gonna be the other way around.
yeah. So this is my negative semi-definite. Okay. And
Hmm.
and if you do both of them, can you see?
Hmm.
If I am not including 0, so only, I mean, the common point, the thing which is left from both of them is this line that will become my indefinite, where it can be positive, it can be negative, right?
Got got it. Yes, this is indefinite.
So this is how you can
Oh,
do it. Now you need to do it. Use this Desmos on your own for all of these questions and ask me questions next day. That where have you stuck? Okay. Now,
okay.
so last time also in previous question we did for positive only. If you can, but now we have done, so it's fine. If in next part let's do for negative. Here, if you see,
Now, how do we do indefinite in this case?
indefinite is always, you will write that wherever it is not semi-definite. See, this is your solution in the book. So they have simply written wherever there is no semi-definite, that what is semi-definite? Including 0, positive, including 0, negative. So
Yeah,
wherever there is no semi-definite,
no,
not
semi-definite.
0, not more than, not less than, just like told you about that line.
It's either positive or negative. And
Yeah.
negative, not all.
Is it fine?
Got it.
Now if you try, uh, which one? Yeah, this one is new. Hold on. What is there in 2023? This is similar, right?
Yeah, very similar.
Okay, so we are
So my
done with
here
all of.
my
Huh,
principal is gonna be B, B, B.
okay.
Then
So let's try this one. This is problem set 1. So they are saying show that general quadratic form can be written. So now I need to show also that this, that is, no, this doesn't look fine. And where is my,
got it. I just
ah,
need to, it's a proof. I need to just multiply
right,
it. This is
right,
AX, XT, AX, the format.
yes. So you
X
need
raised to
to
T, AX.
expand it. But can you see here the matrix, the 2 by 2 matrix which they have given, is this uh what is it called? Symmetric matrix? Is this
Uh,
symmetric?
no, it's not symmetric.
No. So I
It is
need to
square, but
find,
not symmetric.
yes. I The question is asking me, firstly, it has asked me that whether it is same or not. So I need to prove by expanding. This is 1 by 2, 2 by 2, 2 by 1. And then I need to make it a symmetric representation, which we have been doing for last questions, where we have to do what? Principal diagonal, A11, A22,
Hmm.
and then half of the half of both of the products. So A1 by 2 by 2, A1 2 by
A1
2.
2 by 2, A1 2 by 2.
So now this is symmetric. Is this fine?
Oh,
Yeah.
yeah, just one second.
Hmm.
Got it.
Now, if you can try elaborating it, whether I'm getting the same quadratic form or not. Do you want to try?
Yeah, I'll try. Oh, that is going to be x1, x2, a11, a12 by 2, a12 by 2, a22, x1, x2. Now this is going to be a11 x1 plus a12 upon 2 x2, a12 2 x1 plus a22 x2 to x1 plus x2 a11 x1 the whole square plus a1 2 upon 2 x2 x1 x2 plus, yeah, it is, ma'am.
Okay. So first question is done. Now it is asking me to list all the principal minors of a general 3 by 3 matrix. Okay. Can you read the second part?
List all the principal minors of the general 3 by 3 matrix and denote which of the three and which are the three leading principal minors
So it is your
of a
choice. It is
general.
asking about the general. It is your choice whether you want to have it A11, A12, A13, and then you will write the symmetric matrix for it. Or if you want to have ABD form, which we did for 3 by 3. Yeah.
Okay,
And then you
got
need
it.
to elaborate all these general things and the quadratic form and the prime principal minors. Yeah. So let's say if, hold on, if you want to have A11, A12, A13 form, so this will become your x1 square, x2
X1
square,
2 square, x3 square.
right?
Yes.
Then you will be having x1, x2. So you have to have,
Yeah.
a coefficient. What it will be? It will be here A21. Yeah.
A21.
So here also
Yeah.
A21.
A21 x1 x2.
So here it will
Then
become 2A21, right? Double of it.
hmm. Then I'm gonna have A23 x2 x3.
A23. Here,
Hmm. A23 x2 x3.
x2, x3. Then you can
Then
have A1.
A13 or A31
Yeah.
x3 x1.
Yeah. So this is how you can do. I have written the general 2x form and the symmetric one. And then what? It is asking me to find out the principal minors. So you'll write D1, which is A11,
A11 D2 is A11 into A12 minus A21. Uh,
Yes.
Lovely, got it, ma'am.
Great. Now, and also T3, you will do it, yeah?
Hmm.
And then, is this asking for anything else? Denote which are the three leading principal minors. So we have already denoted that these will be the three principal minors. I mean, principal minors. This is the first order
Principal,
principal minor.
yeah,
This
the
is the
three
second order.
principal diagonals.
Yeah.
Got it.
Now, what this third part is called out. Can I
Define the
erase?
definite. Yeah, ma'am.
Okay, now see, this is one question. This is also the way we can denote a matrix with parenthesis. It is asking me
Got it.
about the definiteness, whether it is like the degree of definite thing. So whether it is
Got
positive
it.
definite, negative definite, or semi-definite, or what. So again, you will find the determinant. Tell me the
Yeah,
first order
for
first.
2 into 2 is.
Yeah, first order it is zero, or
Yes.
second order it is again zero.
Ma'am, but then this
Now,
is for 2 into 2, right? For 2 into 2, we use a different way
yeah,
to
that is
get to
also,
know the difference.
yeah, that is also one way. You can do what? X1, X2, 0, 0, 0, C, and then X1, X2.
Hmm.
You elaborate it,
Yeah.
and then you will put the
Yes.
values for X1 and X2.
Lovely. Easy.
If both of them will be positive, you will write it is positive definite.
Positive, semi-definite.
If one is positive, next is negative, so you'll write, now you know, right? And
Yeah.
also, you can say, let's say, answer will come out in the form of C.
Hmm.
Even if you put the value of x1, x2, you still need to know what is the third parameter, which is C, right? So you will say that
Yeah.
definiteness will depend on C. If C is positive, it will make it this way or that way, right?
Got it, ma'am.
Yeah.
Yeah.
Here you can definitely get the perfect answer. There is no parameter.
Yes.
So you will find out D1. Again, you can see from here. Uh, this is not in symmetric matrix form. So you will apply this way. That D1, D2, D3 form we can use you following if it is a symmetric matrix, right?
Hmm.
So you have to again do this way. So try doing it. I'm hoping that we are clear
Ma'am,
with,
but
huh,
yeah, but then as you mentioned,
hmm,
B and C are not symmetric.
B and C,
How
yes,
do we
correct.
do?
So B and C, for that you will do this way. You will do
Okay.
this way, right?
Got it.
Just like
Got it.
here, can you see this is not symmetric, but still we have got the
Hmm.
quadratic form from it. But because of this quadratic, because quadratic form is formed from the symmetric matrix, so we can define it using the symmetric matrix, which we did, the symmetric representation, right?
Yes, ma'am. Got it.
So you need to do it. Also, see, in fourth question, they have asked me, consider this quadratic equation again, this one. Can you change it to symmetric form? Will you be?
Yeah.
And then you have to
Uh,
find out the value of A and B for indefinite. So you will say one way of doing it is because you will be finding the symmetric matrix only, right? Tell me what is the symmetric matrix out of it. A and B will be the leading diagonal, and half of this, that is AB, AB, right?
right.
This is now symmetric matrix. And now it is asking me if it is indefinite, what is the value of A and B? So what will happen? You will find out firstly D1, which is A, then D2, which is
D2
AB,
is gonna be AB minus a square b square.
So you can
Then
take AB common
indefinite, yeah, a less than no, less than greater than 0
and
and less
1
than
time
0.
less than 0. And then you will join both of their inequalities, okay?
Got
And you
it.
will say that for indefinite, it should lie in between these two. And then you
Got it.
have to
Ma'am,
plot.
I'll, for